All right, welcome back, Art22. Here we are in week 3, and week 3 is all about movement. It's all about how can we find more interesting ways to have whatever we're drawing on the screen, shapes, images, whatever. How can we have those moving in a more interesting way and create an environment that is a bit more controlled or contained? So up to now, we've seen kind of 3 ways we've been able to make things move on a screen. First, we saw that we could have the position, let's say we have an ellipse. We saw that we can make the ellipse move by setting its position to mouse X and mouse Y. So wherever we had our mouse, the ellipse followed. We also saw that we could do a similar interaction with the keyboard, where every time we would hit like the right arrow key or the left arrow key, we'd move the ellipse to the right or to the left. And we did that by adding a number to the position of the ellipse. So if the ellipse started off at width divided by 2, we could say +1 and it would move over to the right by 1 pixel, or we could say -1 and it would move to the left by 1 pixel. And then we also saw that we could do that without needing to have interaction. We could just have it in our draw loop somewhere, x++, let's say, where every time the draw loop went through its frame, which is 60 frames per second, every time it went through the draw loop, it would add 1 more pixel or subtract 1 pixel. And that's how we saw this constant motion going in one direction or the other. Now, this week, we're going to be talking about getting motion that's more than just straight lines. We're going to start with straight lines so that we can get multiple directions and things like that. But we're also going to be talking about how we can start to think about both motion, but then also having almost like gravity types of effects. We're also going to see how we can get more organic types of motion with something called both a random walk as well as something called Perlin noise. I'll get to that in a later lecture. But today, the plan is we're going to create an environment that contains our movement a bit more. And what I mean by that is we're going to create a processing sketch that allows us to have a particle or an ellipse moving around the screen. And when it hits one of the edges of the screen, it's going to bounce in the other direction. So if you've ever seen any screensaver from probably 1994 to 2000, this is what we're doing. We're going to have a particle. I keep saying particle because soon we're going to be moving to this idea of particle systems. So if I say particle instead of whatever shape we're working on, just know that that's because my brain is thinking forward to where we're going. But our shape, our geometry, is going to be bouncing around the screen. And so we're going to figure out how we can set that up. And then in the next 3 lectures, we're going to be adding more and more interesting types of movement within that environment. So why don't we go ahead and get the first steps of this setup, and then we'll talk about how we might want to make this bouncing effect happen. So let's jump into that. Okay, so here we are in a new sketch, week 3, class 1A. And what I want to do first is just get all the usual suspects into our sketch here. So I'm going to come down and make our setup section. Setup. And we're going to need a draw section today, so I'll also put a draw loop in here. Okay, so well, let's get a size first things first, right? So how about 600 by 600? Okay, so we know right now that we want to have some 2D primitive, zooming around our screen that'll eventually be bouncing off the walls. So let's go ahead and set up that geometry, that 2D primitive, and let's give it some variables for its position. So let's do this. Here at the top, I'm going to say our position will be given by 2 variables, x pos for x position and y pos for y position. So I'll say position variables for geometry. Okay, And we need to set those to some initial value. So why don't we just kind of go with our typical set them at the middle of the screen. So we'll say x pos is equal to width divided by 2, y pos height divided by 2. So right in the middle of the screen. That's where we're going to start off. Okay. Let's go down here. Let's get a background going. Background. I'm going to make up a color. Well, that's not quite possible. You ever try to think about that? Like imagine a color that doesn't exist? Yeah, food for thought. Okay, so let's go with an ellipse because that's what we've been talking about. We're going to make an ellipse. And what is its x position and its y position going to be? Well, we just said that we want to use our variable x pos and our variable y pos. And we need a size now, right? Because ellipse needs x, y, width, and height. So let's just make it 20 pixels by 20 pixels. How about that? Okay. And just for fun, I'm going to give it no stroke, just the fill color. Okay, so why don't we set up a test for what we want to be doing, which is having our geometry be bouncing when it hits a wall. So first, let's just get some motion set up. So let's just say, for the moment, we want x position to increase by 1 pixel. So we want it to move right 1 pixel for every frame of our animation. So every time the draw loop runs, which is 60 frames per second, we're adding 1 pixel to the x position, so it's moving to the right at 1 pixel per frame. So it's kind of helpful to think about when we're adding numbers to position, almost thinking about it like velocity. Like, you know, in your car you have miles per hour. In animation here, we have pixels per frame. So if I add 1 pixel every time, it means that every frame of our animation, we're adding 1 pixel and it's moving 1 pixel per frame. If I added 10, it'd be moving 10 pixels per frame, so it'd be moving faster. So for now, let's just say we're going to add move to the right by 1 pixel per frame. Let's stay like that just to help illustrate that point. Okay, let's just run this to see where we're at the moment. And there it goes. Off into infinity because we haven't done anything else. So that makes sense. Okay, great. So why don't we draw out what we're kind of thinking here? Okay. So I'm going to zoom in here on our sort of drawn out window, just to pseudocode a little bit what we're looking to do with this bouncing off the wall effect. So let's say this is the right side of our screen here. So this is width right there. And now we have our ellipse that's moving to the right 1 pixel at a time. And what we want to have happen is if it hits the wall, we want it to go back in the other direction. Okay. So one way to think about that, like we could think about it using one of our if statements. That would probably make sense, right? Having a conditional statement. So even without thinking about too much about the code, we could think, okay, if x position is greater than or equal to width, so if it's at the edge of our screen or bigger, we want it to go back the other direction. So we could say something like, if x pos greater than or equal to width, then what do we want to do? So we had been saying this, right? We had been saying x pos plus plus. Now we could say, all right, so we're at width. We've been going plus 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 plus. Now if we're at width or greater, we want to go back the other direction. So we could say x pos minus minus. Okay, that seems to make sense, right? Because we're going to have this thing moving over here. And then when we get to width, we'll start subtracting. Now, full disclosure, there's a problem with this, but I want to go ahead and put it in the code just to see what the issue is, and then we'll see what the kind of the correct or the better way to do this process is. But I think it's informative to see why this doesn't work. So let's check that out first. Okay. So we said, all right, so we're moving to the right, and we wanted to put in this conditional of if our x position is greater than or equal to width. So if we're at the edge of the screen or greater, what do we want to do? We want to then go back the other direction. So go x pos minus minus. Right? Okay, cool. And maybe just to make this fully, actually, let's just leave it there for a second. So let's see what we get when we do this. Okay, there it is, going to the right 1 pixel at a time. Okay. So something's kind of funky with that, right? Let's go ahead and draw out what the issue is here, because we got stuck. We didn't bounce, we just kind of got stuck to the edge of our screen. Okay, so let's think about for a second why this version, which maybe at first seems like it would have made sense, why it didn't quite work. So let's imagine our ellipse got, right here to the edge. And so our width is 600, right? So let's say that the pixel was at, or the x position was at 599. Okay, so it's right before it's equal to or greater than the width. So we're still telling it in our code, all right, we're not at width or greater, so still move 1 pixel to the right. Boom, it moves over to the right. Now it's at 600. Okay, so now x position is at 600, which means the condition of it being equal to or greater than width is now true. So now we have to do whatever was in our if statement, which was now subtract 1, right? Now go minus minus. Okay, so our code is very nice to us, so it says I'll do that. So now x position is back to 599 because we told it to go back the other direction, x pos minus minus. Cool, that's kind of what we want, right? We're going back in the other direction, great. But here's the problem. So now x position is back to being 599, which means it's back to being less than the width. And we know that if it's less than the width, we're going to go back to the x pos plus plus. So now we went back to 599, but because our if statement is no longer true, we're going to go back to just doing x pos plus plus. So what ends up happening is we get this sort of stuck situation where when x position is 599, we're supposed to add 1 to it. Now we get to 600. And now because we're equal to or greater than width, we're supposed to subtract 1. So now we go back to 599. But now we're supposed to add 1. So now we're at 600, 599, 600, 599. So that's why we were stuck on the edge of the screen. We basically set up this situation where we got trapped because of our if statement and our the way we were changing the position of our ellipse wasn't quite working the way we hoped it would. So there's a number of things we could do to make it work the way we want, where it's basically it bounces off the wall and then continues on in the new direction. So a handful of ways to go about that. The way that I want to go about it is to start thinking about how we move geometries or shapes or particles in processing, breaking it down into 2 different components. So instead of just having the variable for position and then just adding or subtracting a number, I want to start thinking about this as having each position have a velocity component, or speed, you could think of it that way, a speed component, and also a direction component. So we're going to separate out the idea of there being speed and direction. And so that's how we're going to be able to achieve the effect of bouncing off the wall and maintaining the new direction that we're going in so that we don't get stuck on the edge of our screen. So let's take a quick look at that. So we need to set the initial condition of these first. So why don't we say, just for the moment, that the velocity of x will still equal 1. So in the same way that we had down here, x plus plus, we're going to say x pos plus equals or equals, or the long form version, which we'll see in a second. But it's going to end up being the same thing, right? X pos plus plus will be the same as adding just 1 or adding x velocity to x pos. We'll confirm that here in a second. And then let's set up the initial condition of direction to be positive 1. And we'll come back and see why we're doing that in a minute, but let's just get it down there and then we'll come back to it. So we'll say initial direction, and we'll say velocity of x pos. Okay, so let's do the same thing. Let's get rid of this. We don't really want that right now. Let's change this now to use our x velocity variable. So what we're going to say is x plus equals, oops, there it is, x plus equals x vel, which, if we recall, is saying the same thing as x pos equals x pos plus x vel. So if that's more clear for you to work with, go with that. Otherwise, here's the kind of quick version, which is just saying add our x velocity to x position. And x velocity is 1, so we're just going to be adding 1 to x position. So it's actually the same thing we just had in terms of the result. It's just a way that's going to set us up for success later on. So let's just confirm that that's still moving to the right by 1 pixel. Yep, okay, great. Now let's try this. What we want to do is now incorporate this direction component into our movement. So let's see what would happen if we had if we start to change around our direction here. So I'm going to do this version now of our movement. I'm going to say x pos equals x. Actually, let's do it this way. So I'm going to say x pos plus equals circling back here. All right, so now we need to incorporate this idea of direction into our new way of doing movement here. And so the way we're going to do that is actually by using the direction and multiplying it to the velocity. And I think once we use it, we'll see a bit more intuitively how this works. But first things first, let's just say that what I want to do is not just x plus equals velocity, not just adding velocity, but I want to add the velocity times our x direction. Okay, now let's see what that gives us, just like that. Okay, nothing different, right? Let's think about why that's not different at all. Why is that not different? Well, x direction just equals 1. So all we're really saying here is x velocity, which was 1, times x direction, which is also 1. And we know that anything times 1 is just itself, right? If this had been 10 times 1, it's still 10. So this has really no effect at all on x velocity other than by, multiplying it by 1, so it's the same number. So that's why we're getting the same result. However, what would happen if x direction was -1? Maybe you'll guess, but let's see what we get here. Aha! So now we're moving to the left. So let's think about why that might be. So in the same way that we know that anytime we multiply something by 1, we just get the same thing, right? Whereas if we multiply something by -1, we change its sign. So if something was 10 times -1, now it's -10. If something was -10 times -1, now it's +10. So having direction be +1 or -1 allows us to change the direction while keeping the velocity the same. So now we've broken down our movement to be into 2 components. We have our speed, which is the same no matter what. It's always, in this case, 1. But now we can just say that x direction is 1 or -1, and that's going to change the actual direction, whether it's going right or left. Okay, so let's just confirm that one more time. I'm going to change the velocity to be, how about 5? So it's moving a bit faster, but we're still going to keep -1. So we should be going to the left by 5 pixels per frame here. Okay, I don't know if you could catch that, but it was working. Window cues popping up on the other monitor. Okay, so quick recap. Motion now has 2 components. It has whatever our velocity is, whatever our speed is, and then we have a direction. Okay, so let's take a look at now how we can try to do our wall bouncing situation with this idea of direction. Okay, so let's again draw this out and kind of make the pseudocode version of how this should work. Okay, so here's, let's say that's our edge of our screen. And we have our ellipse moving this way at a speed of x velocity. And if it's going right, that probably means direction is 1. Direction equals +1. And let's just say the velocity is 1 as well for now. Why not? Okay. So what we need to have happen is not to change plus or minus like before. What we need to have happen is setting up a conditional statement that's going to change the direction when we hit the edge of our screen. So now we don't have to mess with x velocity anymore. We don't have to change the speed. We just need to change the direction when we get to the edge of our screen. So in this case, it would look something more like this. If x pos is greater than or equal to width, let's say, if that's true, and actually we could even simplify this a bit and just make it greater than. Let's just go with that. If it's greater than width, then we want direction to flip. So how do we flip something? And by flip I mean we want it to go from 1 to -1, or from -1 to 1. So the way we can actually do that is just by multiplying it by -1. And let's think about that for a second. So we're going to say x direction let's say x direction equals x direction times -1. So let's quickly make sure we understand that. So if x direction is 1, now we want it to equal x direction times -1. Well, 1 times -1 is -1. So we flipped x direction from being 1 to -1. So we flipped it from being going to the right to going to the left. Now x direction is -1. If we multiply that by -1, so -1 times -1, that equals 1. So now we're back to going direction to the right. So that's how we're going to start to make these direction changes, and that's how we can make these bouncing effect on the walls, is we flip the sign, we could say it, we go from -1 to positive, or positive to negative, whenever we hit an edge of our screen. So let's, so this, what we have right here, would work for the right side of our screen. Now, the cool thing about this is we can actually combine the right and the left side of our screen into one if statement, because basically, no matter what, whenever we hit any edge, we just need the direction to change to the other direction, right? So if we get to the far right side of our screen, we want the direction to change and going the other way. If we get to the far left side of the screen, we want the direction to change and go the other way. So we can actually have our if statement be both if x is greater than width, and, or I guess in this case, or if x is less than 0, change the direction. In either case, if it's no matter what wall we're hitting, the left or the right, we want to change the direction either way. So let's go ahead and put that into our code and just make sure that that's working like we think it should. Okay. So we're going to leave this part as is. And so we need to change this comment a little bit, right? We need to say move by x velocity in the current direction. The current direction, let's put this back to being +1. So the current direction is +1, which means to the right, and the current velocity is 1 pixel per frame. So that's what that's saying. Okay, so now we just discussed that we need to have a conditional statement that checks if we are hitting either of the screens. So let's set up that conditional first. We're going to say if x pos, let's do the right side of our screen first. If it's greater than width. Now, if you remember, we have these two vertical lines as our or. So if x position is greater than width, or x position is less than 0, which is our left side of the screen, if either of those is true, that means we need to change the direction. We've reached the edge of our screen, so we need to change the direction to go back the other way. And we just discussed the way we can do that is by multiplying it by a -1. So x direction will equal x direction times -1. Okay, so let's go ahead and just make sure that this works. Okay, so there it's going to the right. All right, there we go. X direction has changed. Now x direction is -1. Now it's +1. Let's just do one more thing to illustrate this point. So what I'm going to do here is I'm going to print out whatever x direction is. Okay, so we see down here x direction is 1. Boom, now x direction is -1. Still -1, we're still moving left. Boom, okay, x direction is 1 again. So that's what's really happening in this part here. Not sure why the console just went crazy, but it looks kind of cool. All right. So I'm going to comment this out. We don't need to see that every time. Okay, so what we've just done, let's recap, is we broke down motion into speed or velocity and the direction of that speed or velocity. And we've changed that direction based on if we hit one of the edges of our screen. So if we get to the right side of the screen, or width, or if we get to the left side of the screen, or 0, we're going to be changing the direction. So let's get a comments in here. Change direction to the other sign, let's say. So we'll say positive to negative, or negative to positive. And then this if statement was check if we are at the edge of our screen. Okay, great. So that's working like we want. Now let's move from just being in the horizontal direction to also being in the vertical direction, which is our y. We haven't really done anything with that. So let's do this. Let's get a couple of variables for the y aspects now. So we had x velocity. Let's go ahead and make y velocity. So these are velocity variables for geometry. And direction variables for geometry. Okay. So I'm going to copy this line and just change it to y. I guess I could have actually just to keep things, you know, consistent. Let's put it on the same line. Okay, there we go. So now we have a y velocity and a y direction. Now let's make a y velocity that is something that's not 1. Let's go with 3. So velocity of y position. And why don't we start off with the direction of y to be 1 as well. So initial y direction. We'll say x direction. Okay, great. All right, so now this is kind of the easy part. We just basically need to recreate this, but for y. So what I'm going to do is save ourselves a little time here. I'm going to copy this, paste it, and just change the x's to y's, right? Because we have our y position, and we want to add to our y position the y velocity multiplied by the y direction. And now I'll just adjust my comment to make sure that that works. Okay. And now we have to deal with this part. So we have we're adjusting our position based on the velocity and the direction. Now we need to have the conditional statement, the if statement, to check if we're at the edge of our screen in the vertical direction. So if we're either at the top or the bottom of our screen. So I'm going to copy this, paste it down here. I'm going to do Command T to clean this up a little bit. There we go. Okay. So now we need to deal, first of all, with y position. So if y position is greater, well, not width, right? Because width is horizontal. We want to deal with vertical. So we need to change this to height. If we are greater than height, so if we're at the bottom of our screen, good, and then change this to y, and then 0 we can keep, right? Because 0 is the top of our screen. Okay, so that's good. In this case, what we need to do is change this to y direction, and then we can keep that the same. All right, so let's run this, and let's keep in mind now that we have an x velocity of 1, but a y velocity of 3. All right, screensaver achieved. Okay, so you'll notice that this is going to go back a little bit to, you know, math classes of old, but we're getting the overall motion of this ellipse. Think of it almost like slope, right? We are going, for every frame, we're going over 1 pixel and up 3 pixels, or down, let's put it this way, the x velocity is by 1 pixel and the y velocity is by 3 pixels. So that's why we're getting more up and down motion, more y motion, than we are getting the x motion. Think of it like, rise over run in math class of x over y, or y over x, I guess, in this case. So let's just see a different version of this. Let's do it with, how about x velocity being bigger? So how about 6? All right, now you can see we're moving in more in the horizontal direction than we are in the vertical direction. And that's just because the x velocity and the y velocity are, or the x velocity is bigger now than the y velocity. And if they were to be the same, we'd be moving in a straight diagonal line. So let's just check that out. So what if they were both 3? Cool. So now we're just basically going to be bouncing back and forth like this forever because we're moving in a diagonal line, and because we're hitting the corner, both directions are changing, so we just be stuck like this forever. Okay. So let's do one more thing with this, and then see the last thing, how we can easily make this into a bit more interesting kind of art situation. So I want to do 2 things. Let me switch over to the other screen. So we have our thing moving around. That's great. But right now it's static, let's say. So the velocities are not changing unless we stop the program and change the velocity and then run it again. So why don't we set up an interactive way to change the velocity while the program is running? And then finally, let's see how we can make this look a bit more interesting, or like something we might want to make an art piece out of. So we're going to use, to control this, we're going to do a key pressed, and we're going to say, basically, if we hit the key X, we're going to change the X velocity to some random number. And if we hit the key Y, we're going to change the Y velocity to some other random number. All right, so let's check out how we can do that. Okay, so let me pause this. All right, so why don't we do this? I'm going to come down to the bottom here. And I just mentioned that we want to have a check for if we're hitting the X or the Y key. So we've seen in previous lectures how we can set up keyboard interaction. So first things first, we need an if statement. If key pressed. So that is processing's built-in way to tell us, or to check, if we have pressed a key. All right, so now we need to actually check what key it is. So if we said we're going to use X and Y, so if the key that we pressed is equal to X, so we put it in a single quote here. If that's equal to X, we said we wanted to change the X velocity to some random number. So here's how we can do that. We can say X velocity will be equal to a random number. And let's say, how about between 1 and 10? Okay, let's get a couple comments here. Have we pressed a key? Is that key X? If so, set X velocity to random number between 1 and 10. And if you remember, we go up until but not including 10. So technically the numbers we're going to get are between 1 and 9. Great. Okay, so now we just need to do the same thing for Y. We can keep this first one. We still need to check if we're pressing a key. But what we now need to check for is if that key is not x, but y. So I'm going to copy this part here. Okay. Well, Command T to clean that up. All right, now if the key is equal to y, is the key y? And if that's the case, we're going to change y velocity to be between 1 and 10. Or I guess in this case, 1 and 9. All right, so let's check that out. Okay, there we go. Hit X, aha. So we got some different motion there. I'm gonna hit Y, a less significant difference. There we go. There you go, I just decreased X by quite a bit, it seems like. And remember that we can always be printing out what we're seeing if we want to be kind of more clear about what we're actually changing. So what I'm going to do is say, whenever this happens, I'm going to print out, whenever this keyboard interaction happens, I'm going to actually print out what the new velocities are. And when I do this, I'm going to say x vel is equal to So this is just going to help us keep things a bit more clear. So in this case, y, and we're going to print y. Okay, so let's try that again. Okay, so I'm going to hit x. There we go. We see that x is now 6 or something. Let's change y. Y is now 3. X is now 2. And you notice that we're actually getting a couple of these every time we hit it. That's because our frame rate's moving so fast, 60 frames per second, that technically when I hit that key, it must have been held down for at least a couple of those frames. So it did it a few times, but the effect is fine for us because we're just going to end up using whatever the last one of these is. Bring back the sketch here. Okay, great. Now, last thing, and luckily the easiest thing, is we should always remember that anytime we want to change from having a version of our sketch that's just seeing whatever the current position is of this ellipse to seeing all previous versions, we just have to move the background from the draw loop to the setup. And the effect of that is going to be kind of interesting because it's going to be now showing all the traces. We're going to trace out all the positions that this ellipse has been. And I think that's a bit more interesting from an artistic perspective, at least for now. So let's go ahead and see what that looks like. So what I'm going to do is say background. I'm going to copy that and just comment it out down here for now. And I'm going to put that background up in our setup section. So what that's going to do is it's going to draw that red background first, but then it's not going to draw it again. So we're going to see all of the previous directions of our ellipse. So let's just take a look at what that is going to give us. Okay. So we're moving there. Now we can change the X. Aha. Cool. Y different. Y different. All right, so all of a sudden we have this like generative geometry maker thing. And I think you can imagine that this would end up resulting in a lot of cool images you could create that would have this sort of geometric character to them. So I leave that to you to explore what interesting things you could do with something like this. Okay, that is all for now. And we're going to see some more interesting movement in the next lecture.